One of the best ways for students to learn about the properties of similar figures is to construct them themselves. So this video will show you how to construct similar triangles. First, start by selecting the geometry menu. Once we have that selected, we want to draw a triangle, and there are several different ways to do that. One of my favorites is to come down here to the Other Objects tool, select Polygon, and you are going to select the 3 points that you want to serve as vertices for your triangle, and then finish up by reconnecting to the point you started with. You'll notice that when the interior turns a solid color, then you have an actual figure. If you move the vertices around, you will have your choice as far as the shape of triangle that you would like to use. So if we stick with triangle ABC right here, if we want to make similar triangles to this, we're going to use the dilation tool. And in order to use the dilation tool, we need to have a center of dilation. So I'm going to use the point tool, construct a point out into the distance, and then I want to select the entire triangle. I'm going to go back to the cursor tool, and I am going to drag a rectangular selection box around triangle ABC. Once that has been selected, we're going to the construct menu. You'll notice you have your transformation options here. Dilation is what we want. There will be directions at the top of the box letting you know the order in which to select items to make the dilation. Select point, point D. Now notice they're asking us to enter the scale. I'm going to use a scale factor of 1/2, so I'm going to type in 0.5. When I hit enter, I have a newly formed similar triangle. Notice that the new vertices have the prime marks included with them. And while I'm at it, I think I would like to create another similar triangle as well. So I'm going to go back, select triangle A prime, B prime, C prime. The dilation construction menu is still open. Reselect my point of dilation, point D. I'm going to enter in the same scale factor again, 0.5. Once I do this, I'm going to have a third similar triangle with double primes. Now, one thing that you would like for students to investigate are measures of the angles of the similar triangles and the side lengths. So if we go with angle C, if I want to measure all of the angle C's that we have, if you will select the 2 sides that form the angle, that's all you need to do in order for it to know which angle to measure. Go down to the measurement menu, select angle. It will measure and post it for you. If you would like to move the measurement, if you'll click and hold on to the measurement here, then you will be able to drag it wherever you like around point C. We're going to do the same thing for C prime. We'll measure its angle. So notice that we do get the same values there, and students will most likely realize the same will happen once again to confirm. Now, after doing this, you can have students go back and confirm the measurements for angle C, for angle B and angle A, or we can just move on and have them investigate the sides. So now if we want to compare the measurements of the side lengths, if we select one side, let's say BC, under the measurement menu, I want to find the length, 11.26. I'm going to replicate the process for B prime, C prime, and then for the double prime as well. Once we have the 3 values, it would be great to be able to see what is the ratio of the values. Now you can go to the calculate menu to do this. You can also, while you're under measurement, if you scroll over until you see expression, you will be able to enter in expressions that have been calculated from the geometry menu. So I want to see a ratio here. If I want to see the ratio of B over A, I can click the measurements to select them, and the result will be posted for us. Up in the corner, b over a is equal to 0.5. So students will see that the ratio of the side lengths is exactly the same as the scale factor.